In this video, I want to talk about how to rank functions that we've done big O analysis on. So let's say we've done big O analysis on two potential methods, right? And I want to choose them. Choose one of them, right, to solve my problem. So let's say I have my F1, my F2. Well, these are an N. And let's say that the first one is O of N, and the second one is O of log N. So generally speaking, you could just plot the stuff inside, right? You could plot that, you could plot that, and you can kind of see which one grows faster, right? Whichever one grows faster, right, basically is implying that that function takes more operations. But an easier way basically is to look at this hierarchy. So this is very standard. So what this hierarchy is saying is that a log right over here is always going to be less than n to some constant, right? Some power term, right? So what this is basically saying is, oh, hey, this over here is faster, right? This is better, right? This ranking here goes from left to right. So whatever is on the left-hand side, right, this is the best, right? Or I should say this is the fastest. These are all fast, versus these are over here. These are slow, right? These are ones we don't really want. These are the buckets we talked about at the very beginning of this unit. So we're kind of, these are our broad categories, and our different algorithms will go into these different categories. So there'll be O of n, O of log n, O of 2 to the n, O of 2 to the n, right? Something like that. So these are different little buckets here, right? Algorithms that get sorted into the same category here are roughly the same, and we don't really have to worry all that much. Now maybe we can get a little bit more information by doing a tilde analysis, by doing a type bound, but if we just have a big O, effectively they're the same if they fall in the same category. Now if we have, like we have here, we have F1 and F2 where they have different big O's, well we can compare them on this chart, right, and basically say, oh, you know, log n for sure is going to be less than 2 to the n, n squared. And so I'll pick the logarithmic function over the polynomial one. You can see here in the graph kind of just illustrates how these things grow. So you can see, for example, a logarithmic class function, right, goes pretty slow, versus an exponential class function goes pretty fast, right? So there is a kind of a significant difference in between these two categories. Overall, right, again, the idea is, given a big O for an expression, how does it compare between two different functions? Pick the one that's basically on the left side, right? That's going to be the fastest one. Fastest in terms of that growth function has the slowest rate of growth, right? So a growth function, right, as I increase n, the output increases as well. Ideally, right, we want the growth function where we increase n and the output doesn't change all that much, right? It doesn't have to do that much extra work. That is our goal, and that is what's encoded with the hierarchy. So if you're left to compare two things, grab the thing that has the lowest growth.